actually works. Hi.
All right. Awesome.
Welcome.
Sorry about
James,
the technical.
You were born in Oakridge? Oh, no, pardon.
I didn't hear what you said.
I just said you were born in Oakridge, Tennessee.
Yeah.
Do your feet glow in the dark?
I have a nuclear family over there. Mic drop.
That's the best.
Yeah, that's all I'll claim.
Talking to my friend Maggie, who used to work at Oakridge, ORNL.
Yep.
And she said that there were stories about lots of rain and frogs jumping across the parking lot and getting cars running over the frogs on the way out actually set off nuclear alarms at the state border. Does that sound legit?
That doesn't sound unlegit considering. So you got to remember a place a little bit left back in time, because if you roll into Oakridge, it was set up, it was basically what they used to call a holler, just a really big version of that, right? It's all set inside of a series of, they said mountains. They're not real mountains, they're foothills, right? And a defensible spot, right? So you roll down into it, and then you go right past the old gun emplacement that used to have the guard station, and it's still there. So the place really hasn't changed all that much. Now, most of the laboratories and everything else like that are just on the outside of that, closer to Knoxville, but it's all still there. So
I know that at least in Clancy books, do you remember the Clancy book? So there's a book by Tom Clancy where we apparently gave a nuke to the Israelis back in 1973, just in case, that nobody ever knew about, but they ended up finding it, tracking down the nuclear material, and it came from that neck of the woods down there in the TVA area. But anyway, oil and gas.
Well, I think that is a illustrative of the fact that everybody thinks it's a little bit more laid back down there, but when in fact it's not. Dad used to warn us about going into the woods too far because we lived fairly close to some of the facilities, and there was something called duck hunters out there. So if you're from the local area, you know what a duck hunter is, and they're just guys dressed in camo that they look like they're out straight off a hunting trip, and yet they hold a black gun in their hands that looks very, very menacing. So there is that. So you got to watch out for the duck hunters. But yeah.
Wow.
So anyways, how are y'all doing today? So far the conference, I'm gonna personally admit to something right now. I was on earlier, and of course, because I've got presenter level capabilities, I was actually at my son's trying to help out with the field trip, which I was actually had held over because one of the kids got injured, and I was there waiting for the nurse to show up that had to come all the way over from the thing. So I may or may not have put my brand new phone, which I'm not used to using. I'm an iPhone guy, in my pocket, and all of a sudden I realized everybody's wondering, like, why is there noise on this thing right now? And I'm like, oh my God. And I went and killed it as quickly as I possibly could. But that was me earlier, and it was actually a very good video. I really wanted to listen to the CISO video. I actually had a lot of time for the speaker. Although I want to say, when y'all play a video, at least on my headphone combination with GoToMeeting or GoToWebinar, it for some reason completely mutes it, so you barely get any of the audio. So it's like sitting there listening, and then I reached down, put the phone in my pocket to go pick a kid up and put it, and then lo and behold, I'm there blaring soccer games and people with balls and everything else. Anyways, I digress. So I'm going to open that being the
mystery solved.
So thank you, thank you for owning it. You owned it like a boss. But it was epic.
Yikes. So anyways.
We've eaten into your time, and we're just going to let you take it away. You've got a lot of cool stuff to talk about, and you clearly have a background worth listening to.
Let me go ahead and present real quick. Let's see, where's the presentation?
Make sure that you are a presenter. Hold on. James, yes.
There you go.
A little bit how I hunt. for industrial control systems whenever I'm doing pen testing and things like that. And I did pen testing when where it really wasn't allowed to, before the CEH even existed. So, so we'll go a little bit over my background and kind of give everybody in the audience exactly where I'm coming from. I've done this for a long time. If anybody's old enough, they probably know who BBN Planet was. It's actually not really where I cut my teeth. I actually worked at Gateway 2000 before that, before the internet was even around, and as tech support on the phone, telling people how to, and literally emailing them drivers on floppies, and having people walk through about how to fix their Gateway 2000s with a screwdriver. Of course, that was the kind of people that bought gateways, so it wasn't too bad at the time. And this, of course, was before I think Dell was even around. So that's really where I started my career. And then I went over to BBN because I knew some of the people that were in the compute side, and the rest was history. Went off to New York, did some consulting, ended up going down to oil and gas through the consulting thing, and worked for a company called Devon for a while. They had an international group where I did a lot of OT security, and well, it wasn't security at the time. Then it was just called networking, right? So and InfoSec was just sort of something that happened either naturally or not naturally, right? So, and I actually tell stories that sound a little Pyrrhic at first, but they're not at all. We were down in Equatorial Guinea, doing a bunch of drilling, and I was the one flown in to do the satellites and put in the switching and even the telephone and everything else that make it all work over satellite, which wasn't that easy at the time. Now everybody's like, oh, that sounds like it's simple, but at the time it was not a simple job to get done. You saw people downloading stuff over LimeWire, which, or Napster, which was a thing at that point in time, because, you're bored, you're on a rig, you're floating into different places to drill for energy. And because, you're waiting basically to do your work. And so lots of people got in trouble by downloading stuff, and there was really no web content filtering at the time. So you kind of had to, hammer it down what they needed to get to, and then write regexes and, what people could get to and everything else to do filtering and control. So it wasn't that easy. So people got around it all the time, especially with the way peer-to-peer worked at the time, because there was no deep packet inspection in the world at all at that point. I mean, there's Wireshark, or there's actually Ethereal, and then the previous version of that, which I will not name on this phone because it just sounds wrong. So I'm just not going to. It's hard to separate Ether and Ape at the same time. So I'm just not gonna. You see that still, actually, if you go to, I think Black Hat still uses it on the board in the SOC over there. So, and then actually have people downloading stuff. Well, the one thing that was the default share was the actual entire C drive. So you saw very odd IP addresses that not only I recognized downloading stuff directly off the C drive, that was actually some of the production databases for the rigs. And then magically, all of a sudden, all these blue roofs appeared in West Africa, and the Chinese had come in and started investing very heavily into the area, because I guess they realized how much oil and gas was there, because it was actually free to download all that information at one point in time. So InfoSec had its day and age even very, very long ago, even in the OT fields, to keep that stuff, at least at the time, it was air gapped, and now it's less and less so. So we're gonna probably talk a little bit about that, and why IT seems to go further into operational technologies, and with the separation of them are, what the different games are and everything else like that. But I've been around doing this a very, very long time. If you have any questions about any of the companies I've worked for or have worked with for over that period of time, you're more than welcome to call me on the carpet, or even something I might have said in LinkedIn, because that's kind of my platform, my social platform of choice whenever I'm discussing stuff. So one of the biggest problems actually in critical infrastructure and operational technology is actually the pearl clutching that goes on whenever people do start talking about cybersecurity. Because one of the biggest problems that we actually have is actually not talking each other's language. People on the information technology side of the house will say, hey, look, you've connected this stuff to Ethernet. Most of this stuff uses IP as transport, and now you're using, Windows servers and Linux servers and things like that to actually go get your data up out of something they call IEDs. And I, don't want to give anybody any kind of shock with that. The original thing for the acronym was actually Intelligent Electronic Device. And they stopped calling it them as much as that. Now everybody just calls it OT and IoT and IIoT, which is a little softer term than calling something an intelligent electronic device. But that's really what we're talking about. And the base of that is knowing how to take the digital zeros and ones and turn them into pulse width modulation. And if you really want to get down to the very core of what happens in OT, is that pulse width modulation regulates the speed of motors. It regulates whether, temperature control and all kinds of stuff like that. On the basic level, you're actually turning the digital into analog at some point in time, and that's usually through that pulse width modulation and some sort of control fields inside a very, very, very basic microcontroller. And microcontrollers, as we all know, are, if you've played with Raspberry Pi or Arduino or anything else like that, it's really just a memory register to get something to either turn on a 5-volt switch or turn off a 5-volt switch, or 12 volt or 24 volt or 48 volt, or oscillate them on off at different speeds to either make a motor go faster or go slower, or turn a light on or turn a pump on or shut a valve off, or whatever it is on that sort of thing. So that's the problem with that is they use a very, very different, the OT engineers or process control engineers or PEs use a very, very different set of tools. They're basically developers, and there's already a lot of animosity between developers on the IT side and the information security side of the house. I think one of the talks about that was earlier when it talked about DevSecOps, which was a great talk as well on this particular conference, and that actually spoke. And I really wanted to pipe in and say that's exactly the problem in operational technology as well, because people that program the logic are basically just programmers, much, much more low level in some ways, but less and less so, where now some of the stuff that even runs its own API and has its own LAMP stack directly on something called the PLC or programmable logic controller, or if you just want to use the layman's term or the parlance of the field or term of art, it's the controller, right? So the controller of these things, and you can either have the controller built directly into the IED, or you can actually have a controller that talks logic to a group of them, to have something that you're dealing with. So, and most people refer to most of this stuff as SCADA, and that's supervisory control and data acquisition. And so that supervisory portion is the HMI piece, or human machine interface. And what people don't understand is where that looks like just a flat panel to a lot of people. It's actually Windows 10 embedded, Windows 7 embedded, Windows XP embedded in a lot of cases. And essentially it talks Windows protocols because people had to be able to manage those things and talk with the programming interfaces in them. And that's actually, as a prelude to later on in the talk, that's really where we have that meetup of the IT and OT first, is that human machine interface and the engineering workstations, which are essentially user space, where you have a incredibly large amount of control of that user space in that system, where it's much, much harder to lock down. It was much harder to lock down a web server and what you can actually get to in a web server than it is giving someone a Citrix or a VDI, some sort of VDI interface. I can't tell you the incredible amount of lockdown I had to do to give somebody a virtual desktop once upon a time. It's a lot easier now, and it's a lot more ephemeral than it was before, and set to a large degree immutable. But once upon a time, it wasn't any of those things. And so that's actually where we're at still in the operational technology world, where the IT world marches on at a little bit faster pace. OT, because of the physicality of it, because of the sheer amount of investment in a pressure vessel or a pump or a valve or a pipeline, is orders of magnitude larger. And so you have to realize the value out of that over a much longer period of time than you do the IT stuff. And it's not to say that the IT stuff isn't just as important, because data, as people have said, is the new oil. I don't know what that's supposed to mean. It could mean the new water. The new water is the new oil. Who cares what it is? It's just a very valuable commodity in today's day and age. And to that point, let's talk about the differences in focuses between information technology, cybersecurity, and operational technology. So in IT, it's really about the information, right? So some people say the user identity is the new perimeter, because now the perimeter is dead and you have to do zero trust stuff. So things along those lines. I would tell you, I don't really give a darn about the users. I always care about the data. If I'm got my IT hat on, my tinfoil hat, And I'm going to say, look, the most important thing isn't even my users, it's my data that I'm the one that's supposed to manage. That's the first and foremost, most important thing about what I'm doing and what I'm trying to take care of is my data. So really, data is my new, where the data is kept at is my new perimeter, wherever that is and however hard that is to get to. And then, be able to maintain the confidentiality and integrity of that stuff, and even standardization, so you can actually ingest the data very, very easily. So most of the people that have practiced IT security know the big three letters, especially if you're a CISSP, because they drill it into you constantly. And that's CIA, or confidentiality, integrity, and availability. Those are the big three that you have to pay attention to. And normally at this point, I'd point at the audience and say, okay, what are the big three on the OT side? So I can't do that here. I'm just giving a presentation. So I'll give you a couple of hints. You got to manipulate physical things, so you need control of them. They're very, very specialized, and you have to maintain some ability of safety and availability of the whole thing. So normally what I get here is it's going to be availability at the very bottom, the most important thing, whereas data confidentiality is really the most important part of that particular ecosystem, because without confidentiality, keeping integrity and availability is actually very, very hard. So it's kind of the keystone of what you're going to be doing on the CISSP. The same way, most of the people I get that talk to me say that availability is the same way on operational technology. And I tell you, you get close, but that's not really it. Availability is secondary, specifically to safety of the process itself. Now, that doesn't mean the safety of the workers, because unfortunately, I've been, to Baytown, Texas, which isn't too far north and east of me, and maybe places that make plastics and stuff like that. They use something called a phosgene gas. And phosgene gases, you can't actually have the pressure vessel that holds that stuff explode. However, sometimes somebody gets something wrong in a bit of logic, or something happens somewhere, and that pressure gets over pressure, and the thing, instead of blowing a valve and releasing all the gas, they have to do some sort of outgassing. Well, there's a big alarm that goes off, and everybody has to get their PPE on, which is the protection equipment, personal protection equipment. And then they do the release after giving you a certain amount of alarm. Well, if you don't have that on, or you don't know about it, you can't hear the sirens, then all of a sudden you're walking through phosgene gas. And I don't want to tell anybody what that's like, but you can just go ahead and Google it if you prefer, if you really want to be morbid about it. But it is not good for anybody's health, even in this very, very short period of time. So safety, especially safety of the system itself, trumps even the safety of people. And being able to make sure you safely shut down that thing without blowing it up or something bad happen. And availability is always secondary to that, because sometimes the availability of the system gets shut off because maybe the safety part of it is something called a SIS, or safety integrated system, where the safety itself, the logic is actually built directly into the IED that's controlling maybe the pressure on that thing, where it's not even part of the ecosystem. It's not even connected to the ecosystem. It's just, hey, this thing's going into shutdown. It sends out one single signal that's unidirectional saying, I'm shutting down. The rest of this DCS better pay attention, because I'm going to go and shut everything else off as well. And I'm going to try to bring everything down in a very, very safe manner. Well, that happens sometimes. Sometimes it just happens as a blow off or something else like that. And then you end up with larger issues, unfortunately. So those are the big three on the OT side. So knowing that if they had a GIC, what is that? GIAC, it's the GISCP. I always forget with that one too. So pardon me with the acronyms. I don't have my acronymicon next to me. I do, however, have the Necronomicon somewhere in the room somewhere, as you can tell, with all the stuff going on around me. But anyways, bad jokes aside, there are two different focuses, especially when it comes to cybersecurity. And I'll boil it down even further for everybody else here. It's not even the same game, right? If you play it with IT security, it's really a game of keep away, and the ball is your data, right? Sometimes your users, depending on how important they are as well to the whole process. But yes, data is the most important thing. It's really a game of keep away. And I have to join up with Chris Roberts, like him or not. He's right about the hoodie thing, and I just cannot stand hoodies with the hacker thing anymore. And the original term of hacker still makes me draw my fingernails down a chalkboard anyway. So the other one, when it comes to OT systems, is really King of the Mountain. And this is my really, really bad infographic of King of the Mountain, so pardon me for that. But it's really about who has control at that point in time. So it's not even the same game that you're playing when you're dealing with OT security as opposed to IT security. So laying the groundwork for that, the modern systems really, everybody's like, well, connected is hacked, and to some degree, that's absolutely true. So you do have safety systems and other control systems that are completely air gapped away in some cases, especially if the process itself is extremely dangerous, especially for a community or something along those lines, right? So you'll see these safety integrated systems that are going to be completely offline, you know, and maintained by people that are directly on property or on premise. Unfortunately, because people get disgruntled, they are also still at risk. It's not necessarily because of the internet anymore, but it could actually be from the employees themselves, somebody disgruntled or something else like that. And I think when I worked for Fortinet, I think we did a study at the time, and I think it was with Ponemon. Ponemon actually did it for us, and I think almost 83% of all of the actual threats to an individual company or to, you know, people at that particular company are actually insiders, whether through, you know, just incompetence, laziness, tiredness, or what have you going on, or even somebody who's actually malicious. 83% of all the threats whenever it comes to compute systems in general, and that doesn't matter if it's IT or OT, because they're all based on computers, is part of the problem. So knowing where things at are important to protecting them, but it doesn't matter as much anymore, because I've seen people have a better security posture because they're more I would say, what is the word I'm looking for? Careful. I wouldn't even say that they're paranoid, but they're more careful with the way they deploy stuff, even in the cloud. Sometimes simply just because they know that things are easy to reach there. The availability is high. When the availability is high, that means that you've actually to some degree killed some of your information technology capabilities, because sometimes you play the two against each other. If it's highly available, the data, then you can actually end up with lots and lots of cybersecurity problems as well, especially on the integrity and the confidentiality portions of it. And so
James, just so you know, I think the last slide picture was better. The King of the Hill.
This one, vague?
That's a much better picture than the other. Yeah, good job.
I agree. Boiling it down to a kid's game for me is really where it's at, right? Like that's the most important part, because to be quite honest with you, I deal in very, very simple things, right? Easy and simple are two different things. If you keep it simple, sometimes you'll get it right almost every time. It's not about making it always easy, because that can be a different concept. Making things look easy is not always a simple process. So this was taken very recently. And I only show this because, I mean, everybody's seen a picture like this all over the place, but this was something that was taken very recently. I mean, last week even, so I had to include it in this presentation. The first bad thing whenever it comes to where we're failing in critical infrastructure is the use of passwords. If there's one thing that should have been password, you know, without passwords a long time ago, it's going to be really hard to get rid of passwords on the IT side. But on the OT side, because so much of it is based on physical process and people being at places, we should have been beyond passwords a long time ago. And we can do that actually in OT. So OT should have been the first one to get rid of passwords. No more passwords. Please kill the password, right? Knowing what I know about rainbow tables, and I'm sure everybody that's on this cybersecurity conference has done that before and done their CEH and done a brute and knows exactly what's involved in it, how easy it is to do. Please, there's just no protecting against passwords and user identities before. Your identity should have been a token a long time ago, and we should be using something else other than passwords. Having a personal passphrase is fine as part of multi-factor, but it shouldn't be the primary. And unfortunately, right now, we use it as primary because almost everybody uses some sort of hashing algorithm, and then they encrypt afterwards, right? So, you know, we just got to get beyond that, especially in the OT world. We can be the first to get to it even before IT and call that a win on our side because we were the first ones to get rid of it. The second bad thing is bringing IT systems into OT. This is something, I know everybody's like, well, wait, what do? You know, how do you get the data? How do you make an application? How do you get the data out of these IEDs and bring them into the human processing world? Because the other big thing difference between IT and OT is simply that usually when you're talking OT and you're talking OT protocols, it's a machine to machine only. There's no going up and down the TCP/IP stack. There's no layers and OSA protocol. If there are layers, you can follow the Purdue, and Purdue, really the important stuff only goes up to 3. In the same exact way, the most important stuff in OT only goes up to 3 and back down again, because it's machine to machine talking to each other. And that's one of the reasons why some of those OT cybersecurity systems, like one of the companies I used to work for had one of them, is basically, some people call them an industrial IDS. That makes me, cringe again, because it's not, it's an NBAD. Does anybody else know that term? NBAD, Network Behavior Anomaly Detection Engine. So it's one of the things that we attempted to do very early on in the SIM. You can do a little bit of it with some of the better SIMs out there that do this, but it's more of a reactive thing because a lot of the stuff's built on syslog. Deep packet inspection gives you that instantaneous situation. Not that you don't need correlation and maybe even causation in the back if you can get it in the background from your SIM, and you've got your playbooks and workbooks done very well back there. You could probably get from point A to point B a lot better than you might even be able to get to with some of these NBADs. But these NBADs give you a good idea of what's going on behaviorally in the network and where you can sort out the anomalies and easily, because tuning a SIM is maybe 10 to what, it's at least 1 to 2 orders of magnitude harder than tuning one of these NBADs. Especially if you're a domain expert for the NBAD, what the NBAD's doing. So if you're a domain expert in OT, it's much easier to tune it. Sometimes it's almost even child's play for some of the smarter people out there that you see me talking to occasionally on LinkedIn, because they know, stuff about memory registers and programming PLCs and whether or not something is in run mode versus program mode and things along those lines. And those are the things you can see with those NBADs. So the NBADs actually work a heck of a lot better for OT because of the repeatability of the process. It over and over and over again. Things aren't supposed to change. One of the things that people fight in the IT world, as opposed to the OT world, and this is where the OT people kind of laugh at them, is that they have something called cut and paste networking. And I don't know if anybody's ever heard of that term before, but cut and paste networking is one of these things where, because something is Six Sigma or lean based, right, which is something you do something using the process called Kaizen, which is this incremental change to get better all the time, analyzing the process and getting the errors out of it and making the process more repeatable. Well, because the processing is like that, especially on the manufacturing side, oil and gas, energy, water, filtration systems, renewables, all of it's the same, where it's a repeatable process over and over and over again to let the robots kind of take care of the drudgery and make less mistakes. Because of that, there wants to be less mistakes in the programming logic. So what will happen is, what happened was, you would take a block of code out of something and then cut and paste it into something else. And that block of code includes IP addresses, even MAC addresses. So sometimes the MAC address can be the same in one plant in Germany and the same plant in Galveston in Texas, right? So same logic, same IP address schemes, even the same MAC addresses sometimes, because you have a lot of L2 going on in these OT protocols where they don't even go up to L3 to get an IP address. So when you want to do any kind of asset management on the wire or see what things are talking to each other, two objects can look almost exactly like each other, especially if you don't use some pretty deep machine learning with a whole bunch of different aspects and variables actually inside of your ML. So this bad thing, bleeding IT into OT, is one of the biggest problems. So how do you get rid of that, right? They don't obviously mix very well because there's two different ways to go thinking about something. And I'll tell you, here is the answer is already with us, actually. So this is the old way, where you have a lot of user space. And I mean user space, those things where the users have an incredible amount of power. Doesn't matter if it's Windows, I've got Windows a little bit, but it's an incredibly powerful operating system. Linux, Mac OS, which is really just free BSD all over again, Berkeley Systems Development Platform, which is not Linux. And if you say that to the wrong people, they'll probably attack you in the street. So please don't do that. But in these user space operating systems is as safe, I take that back, as secure as a lot of people have tried to make them. It's still in this incredibly powerful user space that if you have physical access to the user space, most likely you're going to be able to hack into it. And that's what the current stack looks like inside operational technology. Remember that long tail on the operational technology, but at the same time, it's the fact that that this process has to be repeatable. So it's just a different viewpoint of trying to keep things the same, but incrementally changing them and not forklifting them to make things just a little bit incrementally better. But we've already fixed that problem in IT. That's the way IT systems were actually set up too before we got something called the cloud, right? So now the web browser, which was posited, I think, actually at the birth of Mosaic, where they said, oh, wait, this thing is going to be the new operating system. Browser is going to be the new operating system. And then I heard it again, I think from Andreessen some other time after that. The answer is already with us, is to get the user space lower in the stack, and the thing that you have as the presentation layer is going to be the thing that isn't user space anymore, right? There's no user control there. You're not logging into a Windows Workstation and clicking on a bunch of things that controls logic directly into the OT world. You have to abstract it again and create a space that is actually no longer user accessible or have all the power that user space had in it before. So the future is upon us. You see a lot more of this in the IIoT, which is similar to IoT, where you have that web server layer, and some of it now has API layers and stuff like that, where you can build browser applications essentially on top of the API. So that's it. We see a little bit in the IoT world, but the IoT is such a brittle stack, even more brittle than the programmable logic controllers that came before it. We're still dealing with some of that brittleness that came for it. So it got a little bit of a bad name initially, as it should have, because it was, when it was in there, it wasn't as powerful as it needed to be, and we reused something too much. When you have a GMO plant and it does something very, very well, I'm not going to pick on corn, but that'd be one of the good examples. All of a sudden you have corn blight or banana blight, and because that banana was so strong and so widely used, all of a sudden bananas go away for a while until we can find a new type of one that goes on. Well, in the same way, there was a lot of operating systems that were reutilized very heavily in some of these spaces where they grew blight. They, had some problems because over time, these things organically happen, both in cybersecurity as well as, bacteria and viruses. It's just the way it goes. So the use of the word virus is actually, I think the only thing we haven't coined yet in this sort of thing yet is the bacteria. We actually need a cyber bacteria, and I think that somebody needs to go ahead and coin that phrase right now and come up with it. And to that degree, there is bacteria out there. It grows, and sometimes it's good for us. And previously, that was in the previous stack that I showed up, which was OPC, which were originally, well, now it stands for Open Platform Connect, and it's really about getting this distributed comm model from Windows, and which is a way to do distributed information basically back into a database to be able to sort it and store it, which is exactly what you need to be able to do very quickly with your data. And so RPC was great back in the day. Nowadays, because of this new cloud stack, we really don't need that layer anymore. We can actually do it either over API, or some people use an MQTT and things like that. So that's some of the bacteria we see still going around the cruft. We really don't need it, just like we don't need passwords. That's sort of cybersecurity bacteria as well. It was good for a while, now it's stuck around for too long, and it is no good for us anymore. So now it's time to start cleaning it up a little bit and getting rid of it, right? In the same way, we see malware going more to the agile field, and waterfall style defenses are no longer going to work. And waterfall style defense is the idea that we had this moat situation that we had before, and people called it defense in depth. And there's some really great stuff in defense in depth. I won't say you get rid of it, but you may need to be able to change the defense in depth to start hunting proactively. And that's where I see the agility of the blue team coming in, is when we start doing these crazy proactive hunts, saying, hey, we see a threat actor doing this. Let's go ahead and try to not just do it to ourselves using purple teaming, but also to have the blue team say, hey, look, as we're going in and doing this thing, this supposed threat on the environment, at the same time, can the blue team defend very quickly on the whole thing? And so I've seen people use stuff like GANCrab and DNS, and if you don't want to use something that's actually more virus driven, you can use DNSCat and Iodine internally to actually see if you can exfiltrate any kind of data out of your system. So it's almost the bottom-up approach to the whole thing. So I've seen a lot of that change, at least in cyber defense, quite a bit. And that kind of leads us to sort of the last aspect of where we're failing in this whole thing. Now, here goes more pearl clutching, and then I'm going to say something that's going to be pretty challenging to a lot of cybersecurity practitioners out there. Please, for all that is holy, do the God's work, and please kill syslog. please, let's get rid of it already. There is already an answer to it. People are using it very effectively. Remember that whole web API thing that I was talking about before? Webhook is so easy and so light, and it gives data tagging capabilities and selectiveness on it and everything else like that. Webhook is here and it's here to stay. Please, let's go ahead and kill syslog, because I'll tell you right now, lots of people complain about how much Bitcoin and Bitcoin mining takes up in the electricity. I will tell you right now, given any single day of the year, syslog takes anywhere between 2 to 10x of all crypto coins ever mined a day is spent on syslog, and that's in your IoT stuff, it's in your firewalls, it's in everything, right? So killing it would actually give us a whole lot of electricity back, just in general, by just instituting webhooks and actually making all that stuff operational. So because not only CPU spent to create syslog, but to ingest it, and then to go store it somewhere, and then you haven't even made, you've spent at least 3 CPU cycles on this thing, and you haven't even made any sense of it yet. So gosh knows, you got to go make sense of it now, and that takes a whole bunch of stuff to actually make sense of syslog and actually know how to correlate, different syslog messages and everything else like that, and try to get to something that's actually human legible and maybe human understandable, right? So, and syslog, where it was, probably possible to get rid of an IT, OT is so much farther behind on this. So much of your billing, if you got a smart meter on the back of your house, it develops syslog to go back to a smart meter that gets collected somewhere locally in a substation that gets pulled up over the wire, and then you have your billing. So even billings based on syslog to some degree, depending on which smart metering system your electrical company is using. So, even that is not exactly the most secure thing in the entire planet. And one of the reasons why everybody complained initially, one of the reasons why they complained initially about smart metering is it wasn't secure, is because it was essentially using syslog to grab the data out of the entire property or the ecosystem itself. So these are where on the OT side, both on the the usage of and then the securing of, we're not doing ourselves justice, because we can move the ball along. There's these 3 holy things that are held up, unfortunately, which are passwords, user space operating systems to make things work, and then the use of syslog to unfortunately secure a lot of what we've got going on. If we were able to transform those into something new, we might get to the next level that we're all really pining for when it comes to defense of critical infrastructure. So that's really my talk today. Hopefully it was informative, and I've left enough time for questions. So, and I'm going to unshare real quick, unless y'all want to talk about a slide.
Now we're all good. Brian, you got anything? And thank you. I know that we had problems at the beginning. You squeezed in. We don't need to introduce the next talk for another minute and a half. So you just made it in. Any questions? Go ahead, Brian. I'll watch.
I was going to say I didn't see any questions, but I thought that was a pretty fascinating insight into your line of work and the things that you're concerned about and want to see changed. There's a little bit of discussion going on there on the Discord.
Yeah, about syslog, so we won't derail on syslog.
Oh, I can't wait to see it. I'll pop in, because I like throwing that stone into the placid waters of cybersecurity, because we can all agree on a whole lot of things, but when you start talking about the things that people make their money on and do things with, and it's really the core value of what it is, challenging something like that is not easy, and I challenge a lot. I actually think that because OT should have charged way farther into containers and cloud stuff and left the actual interconnectivity of the cloud behind. Don't put the internet in it, but I think they should have charged very quickly for it in the cloud infrastructure and putting cloud infrastructure on premises a long time ago to get rid of the user space environments that they currently have. And then that way they could have been a hell of a lot more secure. At least the ephemerality of it and the mutability of the things when you interact with machines would have been a hell of a lot better than it is now. Right now, there's a lot of variability, which causes all the problems that we have today. Thanks, guys. Thanks, everybody. This was great.
Thank you, James. Appreciate it.
James, thanks so much. It's great to hear and watch you talk.